Okay, this is another reaction of magnesium. This time, however, I've got the magnesium wadded up and placed inside a crucible, and oh, it's about to start. I've got the lights turned down a little bit so you can see this a little bit better. I'm going to go ahead and shut the gas off. This time, instead of that really bright white light that we saw with the oxygen reaction, this is more of a sort of a glowing orange kind of reaction. As you can see, hopefully you can see, and there it goes, flaring up a little bit. There it goes. This is the nitrogen reaction. This is magnesium, it's still kind of burning, but not burning in oxygen. And we're getting a little bit of that white oxygen reaction, but what we really want is this sort of orange nitrogen reaction. That's what we're really after here. And it kind of, it's a very, looks like a cauldron from potions class or something. And still going there. I put a pretty decent sized wad of magnesium in there. Anyway, when this is done, okay, what I'm going to do is I'm going to dump this out, dump the ashes out, the product out. This is another one where we have just one product. Ooh, there it's getting really white. Hopefully it's not getting too hot. Must have used up all the nitrogen, and now it's, oh, now it's going back to orange. There we go. Oh, very cool, very cool. So anyway, after this is done, it's still smoldering here a little bit. After this is done, I am going to dump out the contents, and I'm going to add just a little bit of water. And when I add that water, I should get a gas that comes off of that, okay? And what I'm checking for is I'm trying to figure out, okay, what, you know, how can I test the contents of this to sort of verify that this is indeed reacted with the magnesium having reacted with nitrogen instead of oxygen, okay? Looks like it's still just a little bit of a smoldering going on there. I'm going to kind of poke at it a little bit here, break it up a little bit. There we go. Okay. And also what I'm going to do after I add that water, a gas should be given off, but then another substance will be formed as well. And I'm going to test that other substance with what is called litmus paper. You might have heard of litmus paper before. It comes in two varieties. There's a blue and a red. This doesn't look very blue, but that is indeed the blue, and this is the red, which is kind of pink in color. And those are acid-base indicators. And the easy way to remember how it works is B is for blue and B is for base. So if the litmus paper turns blue or stays blue, then it's a base. If it turns red or stays red, then it's an acid. This is another way of testing acids and bases. This is called a wide range pH strip. And it comes with a little color code system right here, and I can sort of match up the pH. Now the way pH works is that 7 over here is neutral, like water should be at a 7. Anything that's above 7 is a base, anything that's below 7 is an acid. So I'm going to test the contents here after I add some water here. Let me adjust the camera a little bit so that we can kind of see what's going on here. And I'm going to dump out the contents. And I may have to scrape around a little bit here to get stuff out of here. Okay. Yeah, I got most of it, I think. Okay. So now I want to take just a tiny bit of water and add it here. And what I should get is a gas that's produced, and that gas, oh, there we go. Now, oh my, you guys of course can't tell this on the video, but that gas has a very, very nasty smell, a very distinctive smell. And that smell, ooh, whoa, it's really filling up the area here. That smell is ammonia. Ammonia is sometimes used in cleaners. Sometimes it's used in just an ammonia solution to clean things. It's also used in window cleaner. It's got a real nasty smell to it. If you've ever used smelling salts before, then that's the ammonia smell that you get from that as well. So that gas that's given off is ammonia. Well, ammonia contains nitrogen. Its formula is NH3. 1 nitrogen, 3 hydrogens. And so that sort of verifies for us that this ash that's left behind from that orange reaction does indeed have nitrogen in it. Now I'm going to go ahead and add just a little bit more water. Ooh, there's some more of that ammonia smell. I can't wait to smell that. And I'm going to go ahead and test this now with litmus paper. And the litmus paper, that one is the blue. It stayed blue. This is the red, and it turns blue as well. So that tells me it's a base. Let me go ahead and test it with this pH paper as well. And the pH paper, I don't know how well you can see that, but it is turning kind of a bluish color. If I compare it to the chart here, let's see if I can compare it to the chart. Probably somewhere, certainly in the base range, right? Definitely not red, orange, yellow, or green. Definitely in the sort of blue area. So probably around 10, 11, 12, somewhere in that neighborhood. Okay, so again, definitely a base that I've got there. Now that I was testing was the liquid that's formed when I added that water. So we've got ammonia gas given off, and we also have a base that's left behind. Now bases typically have hydroxide as the anion, the polyatomic ion hydroxide, OH, as an anion. So let's think about this for a second. When I burned the magnesium in nitrogen, right, we got the nitrogen reaction. That product that I got from that single product, that ashy product that I got from that, when I added water to that, then we got ammonia, and we got a base, which contains the hydroxide ion. Okay?